Whoops. So we're looking at deductive reasoning. I'll just quickly run through some of these with you and then we'll look at some examples. But we're drawing conclusions from facts that are accepted as being true. We start with a general statement or something general and we deduce something specific from it. It's a top-down approach, which is the opposite of inductive reasoning. So I'll sort of explain that a little bit further later on. Here are the steps for deductive reasoning. So 1, we begin with an accepted fact. 2, we continue with the step-by-step statements using logical reasoning. And 3, we ensure each statement is in sequential order and leads to a clear solution. So basically, like we were just talking about, we want to state something and back up what we're saying. That's what it basically comes down to. So let's look at some examples of what this might look like. For the first one, if A equals B and B equals C, then what would you deduce from this? Or what would you say to be true according to this? Then A equals C. Does everyone agree with that? And see that logically that's got to be true. So we're saying A equals B and B equals C. So basically if we substituted, I could just say A equals C. If they're both equal to the same thing, then they've got to be equal to each other, right? If A is equal to the same thing as C, then they've got to be equal to each other. And we can use that in equations. So let's say I had like 2x plus 5 equals 7. And let's say I had like 3x minus 2 equals 7, then I could take them and set them equal to each other if we're looking at what's called a system of equations. So I'll get into that later on. We don't need to worry about that right now. But we sometimes use a skill or a tool in mathematics called substitution. And so this comes in handy when doing substitution. So we substituted out the B and we said A equals C. Good? Since all humans are mortal and I am human, then I am mortal. Do you see the idea? So some of these, this is your math lesson for today. Do you get the idea of how that works? If all dolphins are mammals and all mammals have kidneys, then what can I say? All dolphins have kidneys. Good? If elephants have cells in their bodies and all cells have DNA, then what can I say? Yeah, elephants have DNA. See, it's just applying logic, right? And then eventually using that to back up what you're going to be stating. So determine whether the statement is true. What? That doesn't make any sense. True or false. Sorry. Let me fix this. If the statement is true or false. And then show a counterexample. We kind of looked at this the other day. Every even number divisible by 6 is divisible by 3. Is that true or is that false? Think about that. Every even number that's divisible by 6, then it's also divisible by 3. First of all, what does it mean to be divisible by 6? You can divide it by 6 and get a whole number. So like, what's an example? 12. Okay, so if we look at 12, 12 divides by 6. Does it also divide by 3? Yeah, so that one works. Can you think of another one? What else is divisible by 6? Let's test some. 18. So does 18 also divide by 3? So it worked for that one. Can you think of another? Can you try to think of one where this won't be true? What's divisible by 6 but doesn't divide by 3? So somebody just said 36. Does 36 divide by 3? Yeah, it works for that. So think for a second. Can you think of a single example where this isn't true? So you would say this is true. We would say this is true. Make sense? Okay. If a number greater than 12, I feel like this, a number greater than 12 is divisible by 12. Wait, what? This sentence makes no sense at all. I am going to redo this. A number greater than 12 is divisible by 12 if it is divisible by both 2 and 3. Is this true? A number greater than 12 is divisible by 12 if it is divisible by both 2 and 3. You're going to have to think a little bit about that one and try to think up some examples. Is this true is the first thing we're trying to decide. And then what approach do we take, or what do we do to try to figure that out? And if it isn't true, can you tell me an example of when it isn't true? A number greater than 12 is divisible by 12 if it is divisible by both 2 and 3. Well, is 18 divisible by 12? Okay, so we're saying this is false, and our proof is, let's look at 18. So what you're saying is, why'd you choose 18? Does 18 divide by 2 and 3? Yes, but it can't divide by 12. So this is like our counterexample. So we can say that this is false because 18 does divide by these two, but it doesn't divide by 12. Good. Do we understand that process? So it's basically like a mind shift from what we normally do. Instead of just going through and solving things, we're sort of having to look at them backwards and come up with reasons why they're not true. Actually first deciding if they are true or not, and if it isn't, then we have to come up with a reason for why it isn't true. Good? And also, so that you know, the new way of, I don't know if it's the new way, but sometimes in your workbook as well, you'll find instead of just going through and solving equations as we normally would, sometimes they'll give you questions where you have to determine the mistakes that the person made in the question, right? So I feel like there's a lot of learning that goes on if you are able to point out where the mistakes are. Okay, all students at Lord Byng Secondary School are British Columbians. All British Columbians are Canadian. What can we deduce from this? All Lord Byng students are Canadian. Is that true? Ouch, this is who knew this would get so controversial? I mean, if you don't have your PR card, aren't you not Canadian though? This seems so so wrong to look at it that way. Could we say that you're like an honorary member of honorary Canadian? How's that? Can we throw in that revised little part and say you're like an honorary Canadian? All Lord Byng students are Canadian. Although we did talk about that one slight technical point. Alex? I knew I was going to regret asking Alex.